2020 Telangana Intermediate Maths 1B paper. This is set B. This set here is set B. Section A, first question. Find the value of P if the straight lines x plus P equals to 0, y plus 2 equals to 0 and the given line are concurrent. So these three lines are given as concurrent lines. X equals to minus P and y equals to minus 2. Substituting these 2 points in the other line, 3 into minus P plus 2 into minus 2 plus 5 equals to 0. So we get minus 3P minus 4 plus 5 equals to 0, minus 3P plus 1 equals to 0 and P equals to 1 by 3. This is the value of P. Second question, find the length of the perpendicular drawn from the point to the straight line given. So the length of the perpendicular formula is given as D equals to modulus of AX1 plus BY1 plus C by root A square plus B square. Here it is 3 into 3 minus 4 into 4 plus 10 by square root of 3 square plus 4 square, which gives us 9 minus 16 plus 10 by 5. This is root 25. 9 plus 10 is 19, 19 minus 16 is 3, so this is 3 by 5 units. 3 by 5 units is the length of the perpendicular. Next, third question is, show that the points 1, 2, 3, 7, 0, 1, minus 2, 3, 4 are collinear. So for collinear we can use AB plus BC equals to AC, or also we can use det of these points equals to 0. If I take the det of these 3 points 1, 2, 3, 7, 0, 1, minus 2, 3, 4, that will be equals to, I will expand along the first row. So 1 into 4 into 0 into 4 minus 3 into 1. So it's 0 minus 3 minus 2 into 7 into 4 is 28 minus of minus 2 is plus 2 plus 3 of 21 minus 0. This is minus 3 minus 28 plus 2 is 30, 30 into 2 is minus 60 plus 3 into 21 is 63. So minus 63 plus 63 equals to 0. Hence the points are collinear. Next, third question. Third is done. Fourth question. Find the direction cosines of the normal to the plane x plus 2y plus 2z minus 4 equals to 0. For plane, given plane is x plus 2y plus 2z minus 4 equals to 0. Let us say that my direction cosines with the plane will be Lx plus My plus Nz equals to P. Since these are the direction cosines, I can write that coefficient of x 1 by L equals to 2 by M equals to 2 by N equals to, here the constant is minus 4, if you send that side it's 4 by P. Two by N equals to square root of 1 square plus 2 square plus 2 square by square root of L square plus M square plus N square. Here L, M and N represents the direction cosines. So square root of L square plus M square plus N square becomes 1. So 1 by L equals to 2 by m equals to, this is root 9, which is 3. So L equals to 1 by 3, m equals to 2 by 3, and similarly n equals to 2 by 3. So the direction cosines are 1 by 3 comma 2 by 3 comma 2 by 3. So these are my directional cosines. Next is fifth question. Limit x tends to 0, e power sin x minus 1 by x. I can write it as limit x tends to 0, e power sin x minus 1 by, multiply and divide with sin x on numerator and denominator. So sin x by sin x here, and write this x for sin x. Applying limit x tends to 0, e power sin x minus 1 by sin x into limit x tends to 0, sin x by x. As my x tends to 0, sin x tends to 0. So this formula is that limit x tends to 0, e power x minus 1 by x equals to 1. So in the place of x, I have sin x, even the sin x is tending towards the 0. So this will be equals to 1. And for this, the standard formula is that sin x by x equals to 1. Limit x tends to 0, sin x by x equals to 1. So overall, the answer is 1. Next, sixth one. Compute limit x tends to infinity 8 into mod x plus 3x by 3 into mod x minus 2x. As my x is tending towards infinity, plus infinity, mod x will tends to x. So mod x will be equals to x. That equals to limit x tends to infinity 8x plus 3x by 3x minus 2x. That equals to limit x tends to infinity 11x by x. So x gets cancelled, limit equals to 11. Next, seventh one. F of x equals to x into tan inverse of x, then find f dash of x. F of x is given as x into tan inverse of x. Differentiation, f dash of x will be equals to. So here apply UV rule. U is x and v is tan inverse of x. U dash is 1 into tan inverse of x plus u is x and v dash is tan inverse of x. Differentiation of tan inverse of x is 1 by 1 plus x squared. That equals to tan inverse of x plus x by 1 plus x squared. This is the differentiation, f dash of x. Next is 8th question. If y equals to a into e power nx plus b into e power minus nx, then prove that y double dash equals to n square into y. We have that y equals to a into e power nx plus b into e power minus nx. If I differentiate this, y dash will be equals to a into e power nx into n plus b into e power minus nx into minus n. Differentiating this again, y double dash equals to an into e power nx into n minus n into b is minus bn, and differentiation of e power minus nx into minus n. This gives us a into n square into e power nx, minus into minus is plus, b into n square into e power minus nx, that equals to n square of, taking out n square common, a into e power nx plus e power minus nx plus b into e power minus nx. This part here is a given question, which is y. So y double dash equals to n square into y. Next, ninth question. In ninth question, we need to find delta y and dy. So the formula for delta y is given as delta y equals to f of x plus delta x minus f of x. The given function is that 5x square plus 6x plus 6. So this is my f of x here. F of x equals to this one. And given that delta x equals to 0.001, x plus delta x will be 2.001. The value of x and delta x are given here. So x plus delta x equals to 2.001. And writing this, 5 into 2.001 whole square plus 6 into 2.001 plus 6 minus of f of x is 5 into 2 whole square, minus into minus becomes plus, minus into plus is minus, 6 into 2 and minus 6 plus 6 minus 6 gets cancelled here, and this is 5 into 2.001 whole square. So this value here gives us 2.001 into 2.001. So it is 1 into this is 2001 000. So this is 000 and this will be 2004 1004. So it is 5 into 4.004001. So it is 4.00401 plus 6 into 2.001 minus this is 20 minus 12. So multiplying this, what I get is 20.0200005 plus 12.006 minus 20 minus 12. So this is 0. Subtracting 20 point this minus 20, 0.020005 plus 0.006, that equals to 0.026005. So this is the value of delta y. Now dy will be equals to dy by dx into delta x. So differentiating, what I get is dy by dx equals to, my function is 5x square plus 6x plus 6. So differentiating that, I'll get 10x plus 6. So dy equals to 10x plus 6 into delta x equals to 0.001. X equals to 2. This is 26 into 0.001, which is equals to 0.026. This is the value of dy. Next, 10th question. Define strictly increasing function and strictly decreasing function. A function is said to be strictly increasing if I take a function f mapping from x to r. I can say that this function is strictly increasing if f of x is less than f of y. If this inequality is true for each and every point, then we say that it is strictly increasing function. And if the inequality f of x is more than f of y for each and every point, then we say that it is strictly decreasing. This strictly decreasing function. Next is 11th question. Section B, 11th question. Given A and B are 2 points, find the equations of locus of P so that the area of the triangle PAB. So given A is 2, 3 and B is -3, 4. If I take these 2 points, take a point P such that P is x, y or x1, y1. Area of triangle delta of PAB is given as 8.5. So area of triangle formula is that half into x1, y1, x1, x2, x3, x1, y1, y2, y3, y1. This equals to 8.5. So so take A as x1 and come back to A. So it is 2 x1 minus 3 2, and coming to y coordinate 3 y1 4 3. This is given as 8.5. So expanding this determinant, 2y1 minus 3x1 plus 4x1 minus of minus is plus 3y1 minus 9 plus 8 equals to, if I remove this modulus, I'll get plus or minus 17 here. 2y1 plus 3y1 is 5y1. 4x1 minus 3x1 is x1. x1 plus 5y1 minus 1 equals to plus or minus 17. This is minus 9 minus 8. So it's minus 17. If x1 plus 5y1 minus 17 equals to plus 17, I'll get x1 plus 5y1 equals to 34. Or x1 plus 5y1 equals to 0. So combining these two equations, x1 plus 5y into 5y1 into x1 plus 5y1 minus 34 equals to 0. So this is the given, this is the required locus of the line. So if I remove the suffix once, x plus 5y into x plus 5y minus 34 equals to 0. This is the locus. Next is 12th question. Next is 12th question. When the axes are rotated through an angle 45 degrees, the transformed equation of a curve is given as. Find the original equation of the curve. So here theta equals to 45. We know the formula that these are my old axes and these are my new coordinates. So this will be cos theta minus sin theta and sin theta cos theta. Since I want the original equation, write the new equations in terms of the old equations. So what I get is capital X equals to small x into cos theta, small x into cos theta plus y into sin theta, and capital Y equals to minus x into sin theta plus y into cos theta. Substituting the value of theta, I'll get capital X equals to x plus y by root 2 and capital Y equals to minus x plus y by root 2. So these are my new coordinates. Substituting these in the given equation, the given equation is the transformed equation, which is 17x square minus 16xy plus 17y square equals to 225. And substituting these values here, 17 into x plus y by root 2 whole square minus 16 into x is x plus y by root 2 into y is minus x plus y by root 2 plus 17 into minus x plus y by root 2 whole square equals to 225. That implies 17 into x square plus y square plus 2xy by 2 minus 16 into minus x square plus y square by 2 plus 17 into, this is minus x plus y whole square, which is x square plus y square minus 2xy by 2 equals to 225. On taking the LCM, we get 17x square plus 17y square plus, this is 34xy plus 16x square minus 16y square plus 17x square plus 17y square minus 34xy equals to 225 into 2, which is 450. 34xy minus 34xy gets cancelled. 17x square plus 17x square is 34x square. 34x square plus 16x square is 50x square. 17y square minus 16y square is 1y square plus 17 is 18y square. That equals to 450. Dividing with 2, 25x square plus 9y square equals to 225. So this is my original equation. The given equation is the transformed equation here, and the obtained is the original or the old equation. Next is 13th question. Find the image of the point 1, 2 in the straight line. The formula for the image is h minus x1 by a equals to k minus y1 by b equals to minus 2 of ax1 plus by1 plus c by a square plus b square. Given x1 comma y1 is 1 comma 2. So h minus 1 by the value of a is 3 equals to k minus y1 is 2 and b is 4 equals to minus 2 of. Substituting this 1 comma 2 in this equation, 3 into 1 is 3 plus 4 into 2 is 8 minus 1 by a square plus b square is 3 square plus 4 square. This will be equals to 8 plus 3 is 11, 11 minus 1 is 10, minus 20 by this is 25. H minus 1 by 3 equals to k minus 2 by 4 equals to minus 4 by 5. So h minus 1 equals to minus 12 by 5. H equals to minus 12 by 5 plus 1, that equals to minus 7 by 5. So h is minus 7 by 5 and k minus 2 equals to minus 16 by 5. So k equals to 2 minus 16 by 5, that equals to minus 6 by 5. So the image of the point 1 comma 2 is h comma k equals to minus 7 by 5 comma minus 6 by 5.